Hello, dear student. This is WAEC Mathematics 2026, question 13. Our objective is to calculate the specific value of angle ORQ. Circle geometry problems often require you to identify geometric properties that are present in the diagram but aren't explicitly labeled in the text. The most important rule to remember is that any straight line from the center, O, to the edge is a radius. This means segments OP, OQ, and OR are identical in length. Recognizing these equal lengths allows us to identify specific triangles that follow very strict mathematical patterns, which we will use to determine our unknown values. Look at triangle OPQ. Since segments OP and OQ are both radii, they are equal. A triangle with two equal sides is an isosceles triangle. This means its base angles are identical. Since angle P is 77 degrees, the angle at OQP is also 77 degrees. Consider the full diagram. The entire angle PQR is 130 degrees, made of two parts divided by radius OQ. Subtracting the 77-degree piece from the 130-degree total gives the bottom section, angle OQR, as 53 degrees. By separating the composite angle into its components, we resolve the geometry through simple subtraction. Now we move to triangle OQR. We have our 53-degree angle, and our final target, angle ORQ, is the only piece remaining. Take a moment to apply the radius rule to this new triangle and see if you can determine the final value. Just like before, since radii OQ and OR are equal, triangle OQR is isosceles. The base angles are equal, so the target angle at R mirrors the 53-degree angle at Q. Therefore, angle ORQ is 53 degrees, which corresponds to option B. Proving these angles isn't about complex memorization. It's about applying the property of equal radii to resolve each part of the diagram. Let's verify this with a quick check. If lines OA and OB are equal radii, and angle OAB is 40 degrees, what is the other base angle at B? Because it's an isosceles triangle, the base angles are the same. The answer is 40 degrees. Now, if a total angle is 120 degrees, and one part is 70 degrees, what is the value of the second part? We subtract the known part from the whole. 120 minus 70 gives us 50 degrees. For more deep dive explanations for WAEC, JAMB, and NECO exams, visit QandAhelp.com and remember to subscribe for more updates. Remember this framework. Locate the radii from the center, identify the resulting isosceles triangles, and use the equal base angles to find your solution.